Hope everyone. Jaden dropped a whole pile of stuff on the floor. Oh, it sounded like a whole jar of pens. So on Tuesday, yeah, today's Thursday. Wow. Um, we went over the left-hand side of all of these, so I think now I feel somewhat, well, I can't remember. If I, yeah, I put yeah, the completed practice 1 and practice 2 in the notes there. So they're there to check. I'm sorry my penmanship is awful. If there's any questions on any of those, let me know. What's going on with this now? The airliner's being a little silly. Hopefully that picks up because I don't want to have to. And then practice number 2 was the transition metal one. All of those answers are there. So today we're just gonna, the cations are gonna stay the same. The positive side, regardless of whether it's kind of just a regular periodic table anion or something else, it's the same rules. If it's a transition metal, we use Roman numerals or the multivalent metals. If it's a group 1, group 2, group 3, A1, we don't, and we know that the charges are determined based on the position on our friend, the periodic table. So group 1A is +1, +2, plus whatever. Boron, aluminum are usually +3, -3, -2, -1. Today we need to add, they're called ternary, or something that has at least 3 elements. So if you're looking at something, it has to have 3 capital letters because each element has to have 1 capital letter. So Na, N, and O, N, H, and O. These are the things with the polyatomic ions. These are all in the, most of the common ones are on the chart on your periodic table. And we've mentioned these before. Now we're going to actually use them. Just like the anions, you don't have to really remember anything. Acetate is that. Ammonium, benzoate. There's, I think, a couple that you may come across on those pages that may not be on here. Phosphite is usually the common one, but we'll talk about that in a minute. The name, the formula, and the charge, these are all organized for the most part alphabetically. Yeah, it looks like it, except for these. When you add hypo, per, hydrogen, the kind of prefix sort of things are out there. So names and formulas, and then there's some kind of things to look for. And then we'll talk about practice 3 and 4. So naming an ionic compound with a polyatomic ion is the same as you would name an ionic compound that doesn't have one. Na is sodium. It doesn't need a Roman numeral because it's in group 1. So now we need to look at that whole bit at the end. So this is not sodium nitrogen oxide. That makes absolutely no sense. You're never going to have anything like that unless it's hydrogen something, which I don't think I have an example there. It's always going to be sodium and a polyatomic ion. So that says NO3, so I go down here. NO3 is right there. Let's see if I can, I can't do it that way. Well, NO3 is nitrate. So sodium nitrate. That looks awful. So I'm going to... Sodium doesn't need a Roman numeral. We are recording. CaSO4. Ca is calcium. SO4, I come over here. SO4 is -2, but when we're writing a name, it's not really relevant, is sulfate. Oh, I see. Copper. Copper is a Roman numeral, so, or not a Roman numeral, it's a transition metal, so that tells me I need to know something in here. So we need to know the charge of this. We go back to our periodic table. That said SO3, not SO4. So I see SO3. It has a -2 charge and its name is sulfite. So I'm going to write sulfite down. But we've just looked up that this is -2. This whole bit, because it's the whole thing. So if the sulfite is -2, the copper on its own has to have, it's the balancing charge, has to be +2. So it's the same thing if that was copper oxide that we would have done. Well, we know that's -2, there's 1, so that has to be +2. Same idea, but we have to worry about the polyatomic ions. So far, so good. Let's hope I don't mess this up. I'm going to take your silence as an oak. Period. Yep. So for any of the polyatomic ions, you just use the charge that's there. I don't, the only one that you're going to potentially see that I can think of off the top of my head, there's sulfate and sulfite. There's phosphate and there is a phosphite. Um, there's also, these are chlorine, 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 and chlorine. You can do the same thing with bromine and iodine. But, so, oh, go ahead.
Do you need to find the charge if it's like a transition metal or whatever?
Yep. So like these ones over here, iron is a transition metal, nickel is a transition metal. They're going to need the charge. Anything else is okay.
Okay.
So, oh, still, even though this is at the beginning, this little thing is called, it's NH4. The whole thing is +1. This is the most common positive polyatomic ion, and it's ammonium. NH3, which a lot of you may have in your cleaning supplies closet, wherever. Ammonia. You make ammonium by adding an H to that, but this is a polyatomic ion. So even though it's at the beginning, this is ammonium. O is from the periodic table, so I've got to go over here. O is oxygen, that just turns into oxide. So this is the first one where we have this kind of, well, I guess the second one, but I ignored it up here. These brackets. this bracket, because we have an O and an H, we put polyatomic ions where we have more than one in a bracket because FeOH3 and FeOH3 are two very different things. One iron, three oxygen, three hydrogen. One iron, one oxygen, three hydrogen. I don't even know if that one can exist. So we'll talk about that more a little bit down below. But iron is a transition metal, so I know that needs a bracket. OH, there's more than one element. So I'm going to go back over here. OH, just so we know, is -1, is called hydroxide. So from the other side, that OH group together was -1. So if I have three -1s, the iron has to be a +3. LICN, even it's three capital letters. This is not lithium carbon nitride, it's lithium. Periodic table. CN is the bad one. It's -1, but it's irrelevant because lithium is a group 1A. So that's cyanide. Very dangerous, very poisonous. This is where I like to get kind of fun. Wow, 1, 2, 3, 4 capital letters, 4 elements. But again, it's got that ammonium thing. And CO3, if I go over here, right there, is carbonate. Now, there's no such thing as carbonite, unless you're talking about Star Wars. But I don't know how many of you are going to get that reference. And the last one to write a name for, nickel, is a transition metal, so that means we need this. PO4, oh, well, you can't see, but PO4 is -3, which we'll remember that, and phosphate. So
Is that table on Teams that
the period, the period,
periodic table you have?
I think so. Let's just double check. I'm pretty sure I put one up there. Yeah, periodic table.
The one that you just used right there, like showed all like the
Yeah, it's that exact same one.
okay.
Yeah.
So probably
Yeah.
there.
So phosphate is -3. We have one phosphate. So if this is -3, the nickel must be +3. And this is like where people, the mistake here would be to say nickel is something ridiculous because, well, there's 4 oxygens. There's one phosphate. So that's, other than having to do the odd charge check, all of the polyatomic ions are going to come from your periodic table. There's one that kind of isn't really there, and I'm going to talk about it over here. So on your table, you have SO4 2 minus, SO3 2 minus. Actually going to, whoa, that is not at all what I wanted to do. Oh, you're going to be like this today, are you? Okay. I'm going to move that over here a little bit. So SO4 is 2 minus. SO3 is also 2 minus. This is sulfate, sulfite. There's 3 of these 8s and ites on your periodic table. There is ClO3. This is kind of like the ferrous and ferric, but there's nothing that's changed in this. Chlorate and chlorite. Nitrate and nitrite. So what's the relationship between an ate and an ite in terms, what's the thing that's changing from the ate to the ite? 4 to 3, 3 to 2, 3 to 2. So an 8 has a higher number of oxygens. An ite always has one less. SO4, SO3, 3 to 2. So if phosphate is PO4, 3 minus, phosphite is going to be, now this has 4, so the ite is going to have, oops, 3. PO3 minus 3. So that phosphite isn't on the period or on that periodic table. I have no idea why phosphites exist. There's nothing abnormal about them, but that one isn't particularly on your periodic table, so that's one to kind of think about. So writing formulas, the same thing that we did with um, the regular ionics. We need to know the charge. Well, this is got a transition metal, so I know copper is +2. Sulfate, pull up my trusty periodic table, it says sulfate is SO4 -2. So that's -2. Some people like to just at the start -2. +2 and -2 cancel out, so this is just going to be hopefully something that looks nicer than that. There's 1 copper and 1 whole sulfate unit. And apparently I did all but all of these have polyatomic ions. Iron 3 means we have Fe3 plus. Phosphate we just talked about up there is PO4 3 minus. +3 and -3 make sense, or balance, or cancel, sum to 0. Iron 3 phosphate is FePO4. Gallium doesn't have a Roman numeral, so we need to go to the periodic table and remember that gallium is +3. Just for nitrate is NO3 -1. We know that to balance the negative with the positive, we need 3 of that whole business. So if we need more than 1, we say we need NO3s and we need 3 of them. The brackets and not having the brackets makes a drastic difference. This exists, GaNO33, which has 33 oxygens, would not. Iron is in this case 3 plus. Sulfite we talked about up there is SO3 -2. 2 and a 3 means we want to have a charge of 6, so Fe2. Again, I'm going to need more than 1 polyatomic ion. In this case, it's 3. We have to put those in brackets. This one should be fairly straightforward other than the fact that ammonium is NH4 plus 1. Chloride from your periodic table is minus 1. Those charges balance. So this is just NH4Cl. Barium from your periodic table is 2 plus. That's NO3 minus 1. Just like if we had barium chloride or any mono negative, we need 2 of the nitrates. So that's like all we're adding is one extra thing. Down at the bottom, things to look for to help you. If there's a bracket in the name, that's a charge. So you don't have to use a periodic table. If it ends in IDE, for the most part, it's coming off of the periodic table. There's 2 exceptions that you'll probably see. Cyanide. There's a couple more on this. This is the big thing. If it ends in 8 or ite, it's polyatomic. And that says go to the box at the top. Positive part gets written first. Hydrogen depends on where it's at. If it's the second part, it's a hydride, which is H minus 1, but I don't think there's a whole pile in there. But that's kind of all we have to worry about today. Left side. Now, why, if you caught or were here earlier, well, I guess I should say, are there any questions with writing a formula? See if we've gained a couple people. So formulas, again, it's the same thing. We're just adding that little group of anions. So practice number 3 is write the names. My suggestion, and I would just stick with this side to start, find the transition metals or metals that you're going to need to write or figure out a Roman numeral for. Go through those ones first because this has some of everything. And then, like, if you're new and not familiar, look for that one block that's all kind of stuck together. And I've kind of given you a couple of them there. And then go through and do the rest. The same idea with over here. To the ones that have the multivalency or the transition metal, they kind of stick out a little bit because they have that bracket in there. So start with that part. I have no idea why. One of these days I'm going to have to change this. Here's give the correct name. I'm going to have to change this all to a formula. But that's kind of, I'll go through and finish them or go through some of the answers tomorrow. I'm not sure which. And then that's kind of the end of ionic bonding. I don't know why I have that there. Oh, there was a quiz in there. And then we talk about molecular compounds next. So, any questions? Uh, so, to draw your attention, I'm going to guess most of you have seen it. I put up an assignment. It's the file is going to say quiz, but whatever, it's the same thing. Hey, we're 6. This one has a little bit of a quicker turnaround because it's I think 6 formulas, 6 names. So just number 1 to 12, do all of that business. just so I can see. Molecular compounds will do the same. Then we'll, I think, talk about acids and bases. And we'll do a couple smaller ones. That's why that one has a little bit, like it's not as long as the other one. Tomorrow we'll go through those. I don't know why the cursor's not working up there. But the structures one technically is due tomorrow, yeah. But like someone asked this morning that and most teachers are probably going to pick Fridays for the most part. Um, if you have a pile of stuff for other classes due, and it's like the chemistry gets kind of towards the end, I'm not gonna stress as long as it gets done. Whether it's I'm pretty sure you're allowed to hand stuff in late, um, because like my stuff looks a little different than yours. Pretty sure it says accept late assignments. Allow. I could be a dick and close it, but whatever. I that at this in this instance would be idiotic as far as I'm concerned. Um, so if you're not totally finished, take your time. You can email and ask a question or ask one up in the posts, and I'll try as best as I can to type something in there or point you towards something in terms of um, where we need to go or what would be a hint. But that's all I have for you today. And now I get to go upstairs and watch Ben cheat at goldfish again. So if we're all good, you're free to go. Have a break, relax, enjoy the sun, even though it looks cold as all get out.
Thank
And
you.
you're
Thank
welcome.
you.
See you all tomorrow, or some of you, or most of you.